Let's take another look at how we instantiate an object. This is actually two statements combined into one. The first statement creates a variable called person A that can point to an object of type customer. Its format is very similar to how we define primitive types like ints or floats. Except this statement doesn't create an object, just a variable that can point to or reference an object. It's the second statement that actually creates the object using the new operator. The object's reference is then assigned to person A. Now person A is pointing to this new object. Person A cannot reference an object of a different type. Only an object of type customer. You can just as easily create another reference variable named person B. As with person A, person B can reference a customer object. It currently references nothing. By assigning the value of person A to this new reference variable, you can have it point to the same object. It's in fact very common to have multiple reference variables point to the same object. Let's write a program that picks a winner randomly from a list of 3 customers. We'll instantiate 3 objects and 1 extra object reference named winner. At the start of the program, the reference variable winner isn't pointing to anyone. We then call the Java random function to get a number between 0 and 2. And finally point winner to one of the 3 objects based on the results. Here's our program. First, we create a simple customer class. It has an attribute called name and a single constructor that sets the customer's name. Now our program. Here we instantiate 3 customer objects. Here we define a reference variable that can reference a customer object. It currently doesn't reference anything. Jane, Bob, and Mark are also references. However, they reference the objects we just created. Our goal is to randomly pick one of the people as the winner and then point the reference variable winner to the corresponding object. Here the Java random function is called to return a value between 0 and 2. Here we use multiple if statements to check the result and set winner to one of the objects. For example, this statement sets winner to Bob, so the reference variable winner is now pointing to the same object as reference variable Bob. We now use winner to print the winning customer's name. Let's compile and run. Let's run it again to see another winner. So when we say object Bob, we really mean an object pointed to by a reference variable named Bob. The key concept to remember is that objects are accessed through reference variables. An object can have any number of references pointing to it. If an object ever loses all the references pointing to it, for example by having the references assigned to other objects or set to null, that object, for all practical purposes, will no longer be available. The Java garbage collection facility will periodically look for these objects and delete them. Object references also come into play when passing objects to methods. In actuality, we are not passing objects but references to objects. Let's say we have an online store that carries a large selection of computer-related items. Each item is kept in an object of type, item. Each item has a cost associated with it. But prices often change. Sometimes discounts are offered and sometimes prices on popular items go up. We want to write a method that accepts an item object as a parameter plus a second value representing the price change. The method then updates the price of that item. In reality, we're passing an object reference to the method and not the object itself. Let's write the program. Here's the class item. Each item has a name and a cost. The constructor sets these attributes. Here's our program. First, we instantiate an item object named laptop. The price for the laptop is set at $900. Let's write a method that updates an item's cost. Here's the method updatePrice. It accepts an object of type item, actually an object reference, and a double representing the price change. It uses the reference to access and update the cost attribute of the object. Let's discount our laptop by $100. We'll print the price before and after the update. Let's see the results. Whenever we pass a variable to a method, Java makes a copy of the variable and then passes the copy to the method. This is known as pass-by value. In case of primitive variables such as ints or booleans, the copy has no connection to the original variable. Any changes made to the variable inside the method will not change the original value, since it's a copy. Once we exit the method, the copied variable is lost, and so are any changes to it. In case of objects, since we're passing a copy of a reference, the copy still points to the actual object, and any changes we make to the object using this copied reference will be made to the original object. So although both objects and primitive are passed by value, the effects are quite different. Changes to objects made within a method do change the original object, while changes to primitives do not. Some will argue that this means that only primitives are passed by value and that objects are passed by reference. But as we've just seen, it's a copy of the reference that is being passed. So technically, everything is being passed by value, even object references. Methods can also return objects, or, more correctly, object references. For example, this simple method creates an object of type item using the new operator and then returns a reference to it. Notice the return value for the method is item. So now we can instantiate a particular item by simply calling this method. To accept the return value, we first declare a reference variable of type item, and then call the method. Now we have a reference to the object created by this method. Let's print the attributes of this newly created object using our reference. Don't let all this talk about objects and object references confuse you. In most cases, it's perfectly safe to think about objects and references as being the same thing. Statements like, "We're passing an object to this method," or "This method is returning an object," are fine and are used all the time. However, it is important to understand that it's never the objects themselves that are being passed, but references to them, and objects can have many references pointing to them. We've talked about referencing other objects. But what if an object wants to reference itself? Java provides the keyword this for referencing yourself within an object. So an object attribute can be accessed within an object in the usual way. or through the following object reference. So why reference yourself? One reason is to access an attribute which is hidden by a local variable with the same name. Here's the scenario. Let's say we have a class with two instance variables, x and y. A method in this class, setXY, lets us set x and y to new values. The parameters in this class are also defined as x and y. Probably not a good idea, as we'll soon see. The problem is this. We want to set the class attributes using the parameters. But this will not work. We want this x to be the instance variable that's being set, and this x to be the local parameter setting the new value. The same for the y's. But the local x and y are in effect hiding the instance variables in our class because they have the same name. This is like setting the x parameter to itself, which is not what we want to do. Let's test this. Here's an application class with a main method. We instantiate an object of type XY class. We then try and set both x and y to 10 using the setXY method. Here we print both values. The values were not set. They are still 0. That's because this x and this y are not pointing to the instance variables x and y. But we can access the instance variables by referencing the variables using this. Now this x correctly references the object attribute, while this x is the local parameter variable. Now the values are updated. Of course, we can avoid this ambiguity altogether by picking a more appropriate name for our method parameters, like new x and new y. There are other cases where it's necessary to use this to reference yourself. For example, a method in another class may take as a parameter an object of your class. You can call this method and pass it a reference to your own object using this. This technique is used often when you need to register yourself with another object.